matter. And speaking of dark matter, zombie galaxies might offer unexpected clues. Since star formation can be re-triggered in regions rich in cold gas, tracing these bursts could help map where dark matter is densest, even if it can't be seen directly. In a sense, every rebirth becomes a spotlight on the hidden architecture of the universe. In this way, zombie galaxies are more than just anomalies, they're cosmic laboratories. Each one is a natural experiment, testing how galaxies respond to environmental stress, how they interact with surrounding gas, and how gravity weaves its invisible threads through the fabric of the cosmos. Their sudden awakenings allow scientists to witness galactic change not just in slow, ancient timelines, but in sharp, dramatic episodes, like watching a still painting come to life. These revivals are especially valuable because they may mimic conditions in the early universe. Billions of years ago, galaxies were forming rapidly, colliding often, and swimming in rivers of cold gas funneled from the cosmic web. Zombie galaxies, reignited in modern times, give us a second chance to observe those chaotic, fertile periods. By studying them, astronomers can build more accurate models of how galaxies first formed and how they grew their stars, black holes, and dark matter halos. And there's another layer, one that borders on the philosophical. Zombie galaxies represent impermanence, but also persistence. They challenge the notion of cosmic finality. A galaxy that seemed lost, faded into the background, suddenly roars with new purpose. In their silent, drifting grandeur, they become metaphors for resilience and transformation, echoing patterns we see in nature, biology, even in human history. Just imagine standing on a planet orbiting a young star inside one of these reanimated systems. You might see a sky filled with the scattered remnants of a once quiet galaxy, ancient red stars drifting like ghosts, while newborn blue suns flare to life around you. Nebulae pulse with fresh energy, and the core of the galaxy hums once more with activity. To live in a zombie galaxy would be to dwell in the middle of a cosmic rebirth, surrounded by the strange beauty of a system rediscovering its own vitality. In a universe governed by entropy and decay, zombie galaxies remind us that rebirth is not only possible, it may be written into the very laws of cosmic evolution. And this possibility, that rebirth is not just an exception, but a built-in feature of the cosmos, reshapes how we think about the universe's long-term future. If galaxies can cycle between activity and dormancy, then the grand arc of cosmic history might not be a simple fading into darkness. Instead, it could be more like a rhythm, a cosmic pulse, quiet phases followed by bursts of creation, pauses that end not in silence, but in new beginnings. Even more intriguing is the role these revived galaxies might play in seeding the future. When star formation reignites, so does the creation of heavy elements, carbon, oxygen, iron, all forged in stellar hearts and scattered across space by supernovae. These materials are essential not just for planets, but for life itself. Zombie galaxies, then, may help enrich the cosmos again, sowing the seeds for future planetary systems, perhaps even biospheres. Their revival is not just a resurrection of light, it's a recontribution to the cosmic ecosystem. Some researchers now wonder whether there are even more subtle forms of zombification at work, small-scale awakenings in isolated regions of galaxies, where dense pockets of gas resist the general trend toward quiescence. These mini-zombies could be hiding in plain sight, flickering into activity in the shadows of larger systems. With the upcoming generation of space telescopes, like the James Webb Space Telescope and its successors, astronomers hope to detect these micro-resurrections with unprecedented clarity. And what if there are entirely new classes of zombie galaxies waiting to be discovered? Galaxies that never followed the normal life-death cycle, that flicker intermittently across the eons like cosmic fireflies. Their behavior might be shaped by exotic physics, unknown types of feedback, or even interactions with the dark sector, dark matter and dark energy, whose influence still eludes full understanding. The very existence of zombie galaxies hints at mysteries far deeper than we've yet imagined. In this light, these undead galaxies become not just fascinating objects of study, but portals into the unknown. They whisper of a cosmos more complex, more dynamic, and more alive than we've dared to believe. A universe not content to drift into silence, but one that finds ways, again and again, to stir from the dark and blaze anew. As we continue to observe these enigmatic systems, new questions arise, ones that challenge the very language we use to describe galaxies. What does it truly mean for a galaxy to be dead? If star formation can resume after billions of years, perhaps galactic death is less like a permanent ending and more like hibernation. Could it be that many of the so-called red and dead galaxies catalogued in sky surveys are simply dormant, waiting for the right conditions to awaken once more? This idea forces us to reconsider cosmic timelines. Human history is a blink compared to the lifespans of galaxies, but zombie galaxies remind us that even on timescales of billions of years, transformation is still possible. It's a humbling thought. What we see in our telescopes may only be a single frame in a much longer movie, one whose plot twists are still unfolding in slow, graceful arcs across the canvas of spacetime. Some theorists are even beginning to draw parallels between these galactic rebirths and the processes that govern cosmic structure on larger scales. Could entire clusters or filaments of the cosmic web undergo similar cycles of activity and dormancy? If so, zombie galaxies might just be the visible tip of a far grander phenomenon, a kind of breathing, pulsating dynamic at the heart of the universe itself. And then there's the emotional dimension. For those who look to the stars not only for data but for meaning, zombie galaxies hold a special kind of allure. They are stories of return, of regeneration, of light rising again in places where it was thought to be lost forever. In a cosmos often described in terms of entropy and fading heat, these galaxies are sparks of narrative. They tell us that the universe, while vast and indifferent, also holds space for resurgence. Perhaps, in the quiet light of a distant zombie galaxy, there's a message for us, that even in the coldest corners of time, the possibility of renewal remains. That even when systems fall into stillness, there may yet be movement. And that somewhere, far beyond the stars, the universe is still learning how to begin again. There's a kind of cosmic poetry in imagining this, the ancient skeleton of a galaxy stirring after epochs of slumber, reigniting not with violence, but with a quiet cascade of starlight. One by one, stars begin to form like lanterns in a forgotten cathedral, illuminating the dusty remnants of its structure. Clouds of ionized gas bloom once more, glowing pink and blue, while jets from its central black hole sweep through space like celestial beacons. The galaxy has not only returned, it has remembered how to shine. Some of these galaxies, paradoxically, seem to come back stronger than before. In their second life, they often form stars more efficiently, as if the conditions have matured, as if the galaxy has learned from its past. The chaos of youth has passed. Now, cooled and more settled, the gas collapses into stars with less turbulence, more elegance. It's a rebirth not just in activity, but in character, a refined renaissance rather than a reckless flare. New generations of stars emerge into this reawakened world. Among them are not just massive blue giants that burn hot and fast, but also long-lived, stable suns that may, in time, be orbited by planets. And on those planets, perhaps one day, life. In this way, zombie galaxies may be not only places of scientific interest, but hypothetical cradles of life in phases of the universe we never expected to support it. This connects to one of the most profound questions of all: is life itself subject to the same rhythms as galaxies? If the cosmos produces galaxies that die and return to life, could the same principle apply to biospheres? Could there be civilizations that rise, fall, and rise again, nested within these undead galaxies? Could some ancient beings have once looked up at a dark, quiet sky and watched it brighten again over millennia? It's speculation, yes, but in the vast stage of the universe, time is generous, and surprises are plenty. Zombie galaxies invite us to stretch our imagination not just across space, but across deep time. They ask us to consider not only how galaxies evolve, but how narratives shift in a cosmos that never truly rests. They are a testimony to the unfinished nature of existence, to the idea that even when the light goes out, the stage remains, and the curtain may yet rise again. The concept of zombie galaxies also nudges at the edges of our understanding of cosmic memory. These galaxies don't simply start over from a blank slate, they carry with them the scars, structures, and legacies of their former selves. Ancient globular clusters still orbit them like spectral witnesses. Their cores are densely packed with old stars, stellar fossils from an earlier era. The very fabric of the galaxy's gravitational field is shaped by the mass of long-dead stars and long-since silenced supernovae. So when new stars begin to form, they don't emerge into a virgin cosmos, they are born into a haunted architecture, one shaped by collapse and rebirth, by past light and past silence. In that way, each zombie galaxy becomes a layered artifact, like an ancient city rebuilt upon its own ruins. The new and the old coexist, not in opposition, but in strange harmony. And from a cosmological perspective, this layering is invaluable. It allows astronomers to study multiple eras of the universe's evolution within a single object. One can read the chemical signatures of early star formation in its older populations, and simultaneously observe the more recent processes shaping its new generation. It's like peering into both the past and the present at once, like watching history and prophecy converge in real time. Interestingly, some models now suggest that galaxies may go through multiple zombie phases. Not just one death and one resurrection, but several cycles across cosmic time. Each episode could be triggered by a new influx of gas, a merger event, or subtle shifts in the large-scale structure of the universe. The idea of a galaxy experiencing not one, but many lifetimes stretches our sense of galactic identity. What, then, defines a galaxy? Its stars. Its shape. Its memory. Or its capacity for renewal. In that light, zombie galaxies aren't just astrophysical curiosities, they're metaphors for a deeper cosmic truth. The universe is not static. It is not a one-way road toward heat death. It pulses. It reshapes. It forgets, and it remembers. Even in its most ancient, most quiet corners, there is still motion. Still potential. Still story. And for us, tiny beings observing from a modest spiral arm in the Milky Way, that may be the most humbling and hopeful lesson of all. The cosmos is not finished. It is a living manuscript, still being written, its pages full of stars that fall, and rise again. As our instruments become more sensitive and our simulations more detailed, we are beginning to see these undead galaxies not as rare outliers, but as crucial pieces of the cosmic puzzle. They are not the exceptions, they are part of the rule, hidden until we learned how to listen for their quiet murmurs beneath the roar of the early universe. Like archaeologists brushing away dust to reveal forgotten cities, astronomers are peeling back layers of cosmic time, discovering that the universe is full of these resurrections, slow, deliberate, and glowing. Some zombie galaxies even display hybrid traits, half dead, half alive. Their centers may have shut down, their cores dim and red, while star formation flickers along the outskirts in bright clumps. These galaxies wear their transformation like a gradient across their structure, a ghostly transition from ancient to newborn, all within a single entity. They're not one thing or the other, they're both. Or perhaps something entirely new. This challenges the taxonomies we've built over decades. Our classifications, spiral, elliptical, irregular, star-forming, quiescent, may no longer be sufficient. The universe is revealing a spectrum where we once saw binaries, evolution where we once imagined endings. And zombie galaxies are at the heart of that revelation, showing us that even systems which appear finished may harbor the seeds of future complexity. There's also a philosophical mirror here, one hard to ignore. The galaxies we observe across billions of light-years are, in a very real sense, messages from the past. And yet, these messages are filled with change, proof that nothing remains fixed, not even on cosmic scales. The galaxies we thought we understood have stories we never suspected, and they are still unfolding. In a universe where time moves so slowly, where light from distant galaxies began its journey before Earth had oceans, the fact that we can witness transformation at all is extraordinary. Zombie galaxies remind us that we